one of the areas that we're looking at within Visionaire is network virtual medical applications. And the outline for today's presentation basically is I will give an overview of ultra high definition and the relevance to high resolution medical imaging. Then I will specifically describe what we mean when we say virtual medical applications. Um, After that, I'll give a brief overview of the University of Bristol infrastructure, and then finally I'll discuss how we can proceed towards TNAs within the area of networked virtual medical applications in Visionaire, and then a summary of the presentation. Um, Basically, when we say ultra high definition, we refer to digital media formats that offer larger spatial resolutions compared to high definition. Now, in our first year presentation, we showed a table which I'll show in the next slide. There have been a number of formats proposed for ultra high definition. However, we focus mainly on the prominent formats that have been defined for television broadcasting and also for digital cinema. Within this context, we focus on the Quad HD format, the 4K format, and the 8K format. Now, this table, as I said earlier, shows the different, compares basically the emerging ultra high definition formats with professional HD. And as you can see, in addition to having larger spatial resolutions, we also have significantly greater requirements for network transmission of both compressed and uncompressed content. And as we move towards stereoscopic and multi-view presentation and visualization, you can see that this requirement significantly increased with up to 1.1 terabits per second required for uncompressed distribution of 8K. Now, most people might say, why do you need uncompressed distribution of 8K? But we all know that we're moving towards rich media services for scientific visualization, medical imaging, and for things like this where you have critical data, the ability to provide very high quality content is very desirable. Now, what are the benefits of ultra high definition? Well, when you compare it to high definition, some of the key benefits are that it offers you a greater sense of presence. So the user is able to feel more involved with the content, and it provides, because of the additional pixels, it's able to deliver a far stronger impression of reality. So more of the characteristics of the content can be represented. In addition to that, the viewing angles of ultra high definition content are far greater than you have for HD, and as a result of this, you have more of a natural field of view. We know that with lower formats, you tend to depend on the camera view, but having larger viewing angles with ultra high definition, you're able to more naturally approximate the field of view. Now, from over the years, what we've observed is that ultra high definition is slowly beginning to play a major role. Besides applications for entertainment and cinema, like I said earlier, critical applications are beginning to appreciate what you can do with ultra high definition, and there are more and more deployments of high resolution visualization facilities to support these formats. Now, in terms of medical imaging, the desire to have extremely high resolution imaging is there. And you have traditional applications such as X-rays, MRIs, ultrascans, and these things have been there in the past and they've been working, but ultra high definition and having that ability to represent more data is set to contribute significantly to this. However, as we're moving towards e-health consultations and monitoring and things like remote surgical procedures, having UHD formats is going to make these applications even much better, because you're going to obviously have greater sense of presence, as I said earlier, and better impression of reality. And in case of having real-world surgical operations, I think that this is quite significant. Now, what our immediate focus on within this presentation is towards education and training, because what we know is that to be able to train students and put them in more real world scenarios, real let me say lifelike scenarios from the early stages of their studies. Ultra high definition is set to play a major role, especially with computer generated images, models, and scenarios. And within that, we define virtual medical applications. Now, virtual medical applications to us are applications that use UHE computer-generated models, images, and to an extent require the network delivery or distribution of UHE content. Now, when I say delivery, it could be um, obtaining remote content and delivering it to sites for analysis, and distribution could be basically um, um, distributing content from your site to other people. So maybe having a consultant somewhere else and maybe sending some medical images to them and saying, look, I have this patient and this is what I would like your opinion on this. The two use case scenarios that we consider are education and training purposes where students can be exposed to lifelike environments, as I said earlier, at early stages. And also when you have simulated procedures prior to carrying out the real life procedures. So you can have a simulated procedure where the actual practitioners practice and fine tune their actions um, before they proceed to carry out the actual operations. Now, within University of Bristol, as you know, we've moved from University of Essex and we're still setting up our visualization facility, but through our collaborations here, we have a significant amount of resources. So we have high frame rate capture devices, and these are quite useful, especially when you consider teleconferencing, which are things that we're exploring. And we're hoping to get more cameras because the cameras you see here, um, in their natural state, they do not support live feeds into the network. So we're looking to get more cameras in the future for live streaming, for teleconferencing, and to support the medical applications. In addition to that, we have a number of high performance computing server clusters, which we hope to use to house um, medical applications and other relevant applications so that people can render at faster speeds and basically support high performance applications. Now, one of the things that we've had and we still have is we have a hardware implemented FPGA based JPEG 2000 codec, which allows us to stream up to 4K 3D, and basically allows us to compress from about, if you consider 7.6 gig per eye in a stereo scenario, then let's just assume 14 gig for your 4K 3D. We are able to go all the way from 14 gig down to about 500 megabits per second. So while not, I mean, we consider this to be a very, very useful resource because very few people have this capabilities. In addition to that, one of the things that we have is global network connectivity, and I think this is something I will stress over and over, so I won't discuss the network connectivity. But if, in this area, our work towards a TNA, where we have been collaborating with University of Cardiff to explore how to set up networked virtual medical applications using ultra definition formats. Now, the Cardiff University is the only center in Wales for training therapeutic radiographers, and you can imagine the demand for students who would want to learn this. Unfortunately, this university can only support 20 therapeutic and 35 diagnostic radiography students per annum. So you consider the large number of people who are applying. Unfortunately, I don't have the numbers, but I've been told they're quite large. You can imagine how many people are being rejected. So Cardiff University has been looking at how possible it would be to have education models where not everyone has to be housed at the Cardiff University, and we have been working with them on how to investigate taking their their medical application, which they use for training there, and then putting that through the network with interactivity in such a way that the students still receive the same hands-on experience they would receive as though they were at the site in Cardiff. Now, this is basically a picture of the facility at Cardiff University, and it basically comprises of they've been able to set up their own 4K 3D facility, which has allowed them to do local rendering, and as you can see, they have haptic devices and motion sensors. So with this, students are able to interact with simulated environments and basically be trained from early stages of the education. And from the feedback that the students have given to Cardiff University, this is a I think they really appreciate this. Now, what we've done is we've discussed with Cardiff about the possibility, as we said earlier, rather than just collaborating between ourselves and them and doing a loop back over the network back to them, we have discussed with them about submitting a proposal for a TNA, which would involve multiple sites in Vision Edge to also observe the quality of experience. And this is something that I sent Frederick an email just before the Easter holiday, so I don't know if you've had time to look at it. But what we're looking at is to investigate how having a networking the application basically will affect the quality of experience. As I said earlier, this is very high bandwidth. It has very high bandwidth demands, and because of the interactivity, it has significantly low latency demands also. So besides investigating how the quality of experience is affected, the further aim of the TNA that Cardiff will be hopefully submitting will be to investigate how the remote education model would work based on the experience that we have from this TNA in Visionaire. Now, one of the things that we have suggested to them is to leverage the network connectivity we have within the UHDNet consortium in Visionaire, and basically see how we can stream 4K 3D first to PSNC in Poland, and observe if we have any data loss, what the latency is, how the interactivity, if the interactivity is still maintained, and also to see basically the feasibility of this. And based on our discussions, hopefully the proposal will be submitted before the end of April. Now, just to give you a view of how the setup would look, it basically comprises of the facility in Cardiff. It basically comprises of the facility in Cardiff, and they would have the 4K 3D projection system, the virtual medical environment, and then we would take our UHD content and streaming, UHD codec and streaming servers there, and we've been working towards how to, because it's not a direct interface, so we've been working towards how to interface their system to ours, and then connect via our local NREN network, and also our connectivity to GIANT to the UHD facility in PSNC. Now, hopefully, the proposal goes through and we're able to investigate this. But this is just to give you an idea of the kind of medical applications that we're looking at supporting at the University of Bristol. So, to conclude, basically, I just gave an overview of UHD formats and benefits, and introduce the application of UHD in medical applications, and then in focus on virtual medical applications. Finally, I discussed the University of Bristol infrastructure, and also how we're working towards the virtual medical application TNA in Visionaire.
I would like Henia to ask a question more on technical aspects.
Okay.
Because you started the presentation with a description of capacity of ultra high definition with this table, yes, and you demonstrated that for the applications about there was obviously X-ray, MRIs, ultrasound scans, and so on, which were possible to do and to provide and to visualize for this ultra high definition. I guess when we go to the hospital right now, if we have an X-rays, people still use the analogic developments of X-ray pictures because the specialists feel that the resolution is not enough and they do not see details as they can expect on analogic development and picture on a traditional computer. Do you know or did you have any tests about that in order to compare the very high resolution, even in 4K or 8K, and to be sure that, for example, with these resolutions, it will be the resolution that can be expected by a human eye, and after that, we have the same as analogic displays. Can you
no,
say
we
that?
haven't, but we haven't done any testing. But I have taken your point down. I think it's something that we should look at so that we don't go and make such presentations in the future and people come up with the same points. But thank you very much for pointing that out. But we haven't done any testing. Basically, when we spoke about this, we spoke to a couple of people while we were at Bristol, sorry, at Essex in the public health department, and these were one of the things that they pointed out that they would consider useful. This was prior to us setting up the media lab in Essex. So that it's based on those discussions that we have listed these medical applications. But I think you've made a very valid point, and it's something that we will look to investigate once we have our visualization facility set up.
Will be very interesting to have these comparisons on some conclusions about that, because it will help to say, oh, after 8K, why not 16Ks, and what is the convergence technology? Where do we have to stop? Because 1.1 terabytes per second, it's a lot. Indeed. After that, what will we need if we go on upper resolutions? So I believe it's a very interesting point to know what is expected by an eye for an expertise and to know what is the limit for that.